This tutorial will explain the process in the formation of solutions. Enthalpy changes, or delta H, in the formation of most solutions involve differences in the attractive forces between the solute and solvent particles. In order for the solvent and solute to mix, first you must overcome all the solute-solute interactions. Note the word all here. So every single solute has to be taken apart. Some of the solvent-solvent interactions, so therefore some of the solvent interactions will remain, but you still have to make room for those solutes to be mixed together. Both of these processes are endothermic. In other words, you have to put energy in to separate these interactions. So here's the solute. The solute have to be separated in order to be placed into the solvent. The solvent also needs to separate a bit to make room for the solute particles. And then the solution is putting these two things together to be mixed up. The solute and the solvent separation will be endothermic. The degree as to which, the magnitude at which these two are mixed together, that delta H will determine whether or not the solution is actually made. At least some of the energy to do this comes from making the new solute-solvent interactions, which is the attraction, which is the delta H of the solution. This should be exothermic. The solution interactions involved are the solvent-solvent interactions, the solvent-solute interactions, and the solute-solute interactions. So these two must be overcome to make way for these solvent-solute interactions. If the solute-solvent interaction is greater than these interactions added together, the solute-solute and solvent-solvent interactions, the solution forms. If they're approximately the same, the solution forms. However, if they're less, then it becomes questionable. It may or may not form the solution. If the energy difference is small and entropy is greater, so in other words, if the desire to be mixed up is greater, then the solution will form. Otherwise, it won't form. Now, we have said before that like dissolves like. So that means polar molecules and ionic molecules will dissolve in polar substances and polar solvents. Water is a polar substance. Oxygen is more electronegative than hydrogen, so therefore the electrons drift to get a net polarity towards the oxygen. So what you have to ask yourself when you're deciding if this is soluble in water or not, look at the compound and look if there's areas of electronegativity, if there's areas of polarity. We have a polar end here, we have a polar end here, here, and here. We also have the oxygen here and the oxygen here. This leaves a lot of areas where there can be hydrogen bonding with that water. So therefore, this is considered a polar molecule. Therefore, it is actually soluble in water. However, if we look at the vitamin K, yes, we have oxygen here and oxygen here, which would then have the electrons drift towards it. However, it is symmetric, which leads us to believe that this would then cancel out, making it potentially nonpolar. Because it's nonpolar, it will not dissolve in water. And that is how solutions are formed.